with it. We're currently in the process of getting into a more experimental stage with doing actual straight-faced walls. I can go into that in a little bit more detail. We're still in a testing stage in some of that, and so I don't want to go into too many specifics. We built a wall, a structural 8-foot by 8-foot wall similar to the one that was in the last demonstration. Sent it up to WSU's testing lab. So we actually have data on that. Went through shear test, compression test, and everything. So we do have some data on that, and I can go into that.
Just the quads spanning it.
Just
That's
quads,
right.
and they're actually in a
4-frequency layer,
Yeah.
you know, where you change the orientation and, you know, vertical, horizontal. We did a 4-frequency layer, and we had 750 pounds per linear foot with 1/10 of an inch of movement. And that was at 4.5 kips. We pushed the corner for our shear to 6.5 kips, and it did not shear. It just tipped the wall and tore the hold downs that we were using. So we had to go back to the drawing board for hold downs. But as far as shear goes, this wall will not shear. It's
2 plies of quads.
exactly
4.
four actually.
4. Yeah. 1, 2, 3, 4. But, you know, we can settle for 3. If 4 gives us 750 with 1/10 of an inch, we're fairly certain that 3 would be the best thing.
That's a lot.
But you could do, again, we were testing, this is a technology we were testing, so we're still...
Can you do a 4-inch wall though?
Sure, that's it right there.
Yeah, that's this is a 4-inch wall.
Straight wall, absolutely, not a problem. And we did the 2-lane tests with beamwork and going with stacked up quads, up 4 stacked and plastered, getting up to 70% of Doug fir on beamwork.
Okay. So what are the advantages of StrawJet? Obviously you guys are familiar with the straw advantages, but it's a rapid deployment system. It's very quick. I mean, our stuff is trailer mounted. We can just take it out and go for it. You don't have to get all kinds of giant equipment in place and so forth. It's very easy to construct, minimal operator training. Like I said, you guys will go out and play with it. You can start wrapping quads right away. It's a very small form factor. Village-based, and we did do this, or you can use it for industrial operations. Our actual cable machine pumps out, was it 2 miles an hour?
1.5 right now,
Yeah.
but we only slow it down because people are slow.
Yeah.
It'll go to 5 without a problem.
You can crank cable out of this thing as fast
5
as
miles
you
an
want.
hour.
So it'll really do that. It's portable. It has little or no ecological impact. So I mean, it's a fully mechanical process in that sense. It's very cost competitive. There's no hazardous glues or chemicals involved. It's a completely mechanical process, compression process. So you don't have any sort of glues that you're adding into it or anything of that. One of the things that's nice about it, I mean, you guys obviously are familiar with it. We can sequester carbon using this technology to help offset some of the other building mechanisms that are being used. And it reduces waste. So you already build with straw. You're familiar with why straw is a good building product in that sense. It's kind of a nice thing. What can we use for feedstocks? Well, this kind of just gives you an idea. We've used cereal stocks, so rice, maize, wheat. We've used commercial stocks. We've done tobacco, hemp, which everybody likes to look at the hemp product, but we don't use the kind that's got the leaves that get you high. Jerusalem artichoke, sunflower. We've run bamboo through it, river reeds, wild grasses. We're always looking for new stuff to run through it. Again, like I said, any naturally occurring local feedstock. You're not transporting building materials. It's one of the concepts of our design. So you just do it right there and build with locally.
I think the perfect material to use for this would be cattails or tulies. Ever try that?
Actually, you want to talk to my...
Cattails, yeah, you can use virtually anything depending on what you're trying to do. If you want structural archwork and beamwork, you're going to stick more towards the bamboo and palm frond direction.
Yeah.
But if you want insulation, you're going to move towards the sunflower direction,
Okay.
you know, and corn stalks and things like that. So you just go out in your landscape and get a sketchbook and design up your house right from what's growing there.
There's all kinds of cell structure in
Absolutely.
a tule stock.
Right.
Modern combines, they leave straw. They leave straw about 3 inches long, 3-4 inches long.
Yeah, we've actually been dealing with that with a couple of different farmers. You can get that, we've talked to the farmers, especially up in the Klamath Basin, which is not rice, this is
Wheat country,
straw.
yeah.
But they're willing to adjust their combines to get to the right length so that we can get the most length out of our feedstock.
It's ideally suited for stripper-headed crops.
Swamp is not, isn't good.
Chaff doesn't work.
Yeah.
Yeah, our machine doesn't do anything with chaff.
Doesn't make any members that are worth using.
So you could,
It's just hard to work with. So most combines, yeah, they turn what they don't bale, and what they do bale kind of gets so smashed up
well,
that it's not much use to us.
Dennis over there does used to do rice straw that was 10 or 11 inches long, but the modern combine, he had to switch to one of those because they were way faster if you make money out of it. Instead of,
Yeah, stripper header works the best, where they just come in, take the grain off, and leave the straw. You can come in and just run a 4-cable machine through there and make houses at 20 or 30 an hour.
Right. This is a linear extrusion, so the longer the fiber, the better the product.
Well, the opposite of that, what's the shortest practical fiber?
1.5 feet, probably, foot.
Yeah, foot. Yeah. We go with foot. After that starts getting,
You'll have failures around a foot starting to show up.
and it just doesn't have any rigidity then. Because one of the nice things about the way is it's orienting the straw, so you're getting a lot of the structural component out of just the natural fiber and the length that's built into it.
Question? With the different types of material that you've gone through, do different materials kind of chew up the machinery more than others? I mean, I understand even with baling, rice kind of it's harder on the machinery.
Not really. The machine that you're going to look out here has 20,000 psi concrete rollers with steel and reinforcement in them. That'll take 4,000 pounds before they blow up. So we're probably pretty good.
I don't think we're going to have any trouble. I mean, granted, rice straw is notoriously rough on equipment, and
Sharp edges is big more.
And lungs. Lungs. It's this rice is nasty on lungs. Ooh, scary.
And I'm sorry, one other question. The amount or the degree to which it's compressed. I mean, do you get like a pound per cubic foot?
yeah, we actually have an adjustment on our, we call it a feeder meter, and we can go out and show you on the machine, that actually changes that. So it changes how much rice or feedstock you're throwing into the machine at one time. So you can adjust and fluctuate that.
Anywhere from 15 to 45 psi, right on one of the side bundles, before it gets compressed. So we kind of meter it lightly to get a consistent feedstock to the compression rollers, and they're trimmed off if there's extra material. But the pressure going into so we can actually dial